Maps conjure up images of travel, adventure, and discovery. On road maps, the depiction of highways, cities, water bodies, and other map features guide you to your destination. As a pilot, you'll find that maps are essential in guiding you to your destination. Aeronautical charts are maps that provide a detailed portrayal of an area's topography combined with aeronautical and navigational information. But before you learn about the specific features and symbology on VFR aeronautical charts, you need to understand some basic concepts that apply to representations of the Earth's surface on maps. When your friend says, "I'll meet you at the corner's your reference point. But if you look at a globe, reference points are sometimes difficult to locate. To make it easier to locate points on the planet, cartographers developed a system of imaginary reference lines on the Earth's surface, known as lines of latitude and longitude. To create a flat, two-dimensional representation of a three-dimensional spherical object, cartographers developed a technique called projection. Additionally, just as there are specific tools for specific jobs, certain types of VFR aeronautical charts are more suitable than others for specific types of navigation. The basic types of aeronautical charts used for VFR flight navigation display similar symbols for airports and many other chart features. The significant differences among these charts are in the amount of geographic area and detail each type displays and how the charts are typically used. When you're planning or executing a flight, knowing the height of the terrain along your intended route is critical to your safety. VFR aeronautical charts show the terrain elevation information you need to choose a safe maneuvering or cruising altitude. The ability to interpret contour lines, color tints, and spot elevations on these charts is a fundamental aviation skill. The legend on a VFR aeronautical chart is your tool for deciphering symbology and decoding aeronautical chart information, including airport symbols and airport data, navigation aids and communication symbols, topographic information, and airspace and obstruction symbols. Your course through this lesson on aeronautical charts directs you into the following topics: latitude and longitude, projections, types of aeronautical charts, chart terrain and elevation, and chart symbology. To travel from place to place in the city, you typically navigate a network of streets. When driving to your friend's house, for example, you know to turn right on Main Street and then left on Riverside Drive. Main and Riverside are clear reference points. But what if you had to locate a point in the middle of an ocean? To help in designating locations, cartographers created a logical grid system made up of imaginary reference lines on the Earth's surface, known as lines of latitude and longitude. Latitude lines, which are often called parallels, are parallel to each other and to the equator. The equator is the imaginary line that circles the Earth midway between the North and South poles. The Earth can be divided by imaginary lines that create great circles and small circles. Great circles are the largest circles that can be drawn on a sphere, such as the surface of the Earth. A great circle's plane passes through the center of the Earth, dividing it into two equal parts. The shortest route between 2 points on the Earth's surface follows the path of a great circle. In contrast, the plane of a small circle does not pass through the center of the Earth. The equator is a great circle. All other lines of latitude are small circles. Lines of latitude are measured from the equator. They are therefore designated as north or south of the equator. Latitude lines are identified by degrees ranging from 0 degrees at the equator to 90 degrees at each pole. At the north and south poles, 90 degrees actually refers to a single point. The degree of latitude correlates to the angle between the equator and the line of latitude with respect to the center of the Earth. For example, 45 degrees north latitude corresponds to a 45-degree angle between the equator and the 45th parallel. The same relationship holds true in the southern hemisphere at 45 degrees south latitude. distances remain consistent between each degree of latitude. For example, the distance between the equator and 1 degree line of latitude north or south is 60 nautical miles. Therefore, the distance between 89 and 90 degrees of latitude is also 60 nautical miles. Longitude lines, which are often called meridians, are imaginary reference lines on the Earth's surface that run north and south between the poles. Because they connect the poles, lines of longitude always are given in a direction of true north and south. Lines of longitude cross the equator at right angles. If you remember, slicing the globe along lines of latitude north or south of the equator creates smaller and smaller circles. In contrast, slicing the globe along any meridian or line of longitude produces a great circle. Lines of longitude are measured from the prime meridian. The prime meridian is designated as 0 degrees of longitude and passes through Greenwich, England. Longitude lines are designated as west or east from the prime meridian. Lines of longitude are identified by degrees. There are 179 equally spaced lines of longitude to the east of the prime meridian, and 179 equally spaced lines of longitude to the west of the prime meridian. The remaining 2 lines of longitude are the prime meridian at 0 degrees and its counterpart on the opposite side of the globe at 180 degrees. Neither of these meridians uses an east or west reference. The international date line approximately corresponds to the 180-degree line of longitude. The general concept used to determine lines of latitude is applied in a different orientation to measure lines of longitude. The degree designation for a line of longitude correlates to its position in relation to the prime meridian. This example depicts how a 50-degree angle of longitude east of the prime meridian translates into the 50-degree east meridian. Unlike lines of latitude, where the distance between each degree is always 60 nautical miles, the distance between adjacent lines of longitude varies in length depending on the latitude or distance from the equator at which it is measured. For example, if measured at the equator, the distance between adjacent lines of longitude is approximately 60 nautical miles. The distance becomes smaller the farther you are from the equator, falling to 30 nautical miles at latitude 60 degrees, and shrinking to 0 miles at either pole. An aeronautical chart displays lines of latitude and longitude as a grid pattern. The grid defines a fairly large area. On its own, it often cannot precisely define a point on a chart or the Earth using only degrees. The concept of minutes and seconds was introduced to provide a method for further defining geographic points within a given grid. Degrees of latitude and longitude can be divided into minutes. There are 60 minutes in each degree. VFR aeronautical charts use tick marks to depict minutes on latitude and longitude lines. This graphic shows degrees and minutes. Minutes are marked with a symbol called a prime, which looks like an apostrophe. You can see a prime in this example with 30 minutes. Minutes can be further divided into seconds, which are often marked with a double prime. There are 60 seconds in each minute, although VFR aeronautical charts typically do not depict seconds.
You can use minutes of latitude to measure distance. Each minute is equal to 1 nautical mile. For example, to measure the distance between Mentone Airport and Fulton County Airport at Rochester, you can use the latitude lines. The distance is 8 nautical miles. You can verify this by using the nautical mile scale on the chart. Make sure you don't measure distances using minutes of longitude, because those distances will vary depending upon their position with respect to the poles.
Now that you understand the basics, you can begin applying the concepts you have learned to determine coordinates for a location or find a location when you know the coordinates. Every location on the globe or on a chart corresponds to the intersection of a line of latitude and a line of longitude. This intersection is called the coordinates for the location. By knowing the geographic coordinates, you can locate any position on the Earth's surface. To determine the coordinates for a location on a chart, identify which lines of latitude and longitude intersect at the location. You always give latitude first when stating coordinates. In this example, you can see that Comanche County Airport is located south of Coldwater, Kansas. But what are its coordinates? Latitude for this location is at the 37th north parallel, or 37 degrees north latitude. The number of minutes north of the latitude line is approximately 14. So the approximate latitude for Comanche County Airport is 37 degrees 14 minutes north. Longitude is at the 99th west meridian, or 99 degrees west longitude. The number of minutes west of the longitude line is approximately 20. So the approximate longitude for Comanche County Airport is 99 degrees 20 minutes west. The coordinates for Comanche County Airport are approximately 37 degrees 14 minutes north latitude and 99 degrees 20 minutes west longitude. Sometimes you know the latitude and longitude coordinates, and you need to find that location on a chart. To determine a location on a chart from the coordinates, identify the point at which the lines of latitude and longitude intersect. For example, let's say you know from the airport facility directory that the approximate coordinates for the Fairview Municipal Airport are 36 degrees 17 minutes north latitude and 98 degrees 29 minutes west longitude, and you now need to locate the airport on your chart. First, locate the 36th parallel and move approximately 17 minutes north on the scale. Next, move to the 98th west meridian and count approximately 29 additional minutes west. Located at the intersection of the two coordinates is Fairview Municipal Airport in Oklahoma. The latitude and longitude coordinates for most airports are measured at the official airport location or airport reference point. Could you imagine trying to consult a big round globe in the cockpit, or trying to measure nautical miles along its curved surface? Fortunately, you have aeronautical charts to guide your navigational efforts. To represent three-dimensional spherical objects, such as the Earth, on a flat, two-dimensional map or chart, cartographers developed a technique called projection. This technique is used in creating aeronautical charts to ensure that the charts accurately portray the Earth's topography. To help you understand the challenge of using projections to create charts and maps, consider how the curved surface of this orange peel becomes significantly distorted when it's pressed flat. Distortion is inherent in all maps and charts that are created using projection. As you will see, different projection types have been developed to minimize these distortions. Mercator projections are developed by transferring the surface of the Earth out into a cylindrical shape. The Earth's meridians and parallels are represented by two sets of parallel lines at right angles to each other. Mercator projections are the basis for many classroom wall maps. When projecting the Earth's surface onto a cylinder, distortion of a land mass increases with its distance from the equator. For example, despite the appearance of this map, Greenland is actually only 1/8 the size of South America. Lambert conformal conic projections are derived from mathematical formulas that give them the property of conformality, as though they were based on a cone that intersects the Earth's sphere. Charts based on Lambert conformal conic projections do not display significant distortion as long as they depict only a small area of the Earth's surface. When you compare miles on a Lambert chart to actual miles on Earth, the overall scale inaccuracies are insignificant on a single chart. Aeronautical charts are small enough that distortion is negligible with Lambert projection. So that's the projection technique on which the aeronautical charts you use are frequently based.